8B notes are on geometric sequences and series. Geometric is multiplying sequences. That is like an example of a sequence for a geometric would be 2, 4, 8, 16. You multiply by 2 each time. And a series, an example of a series would just be, we use that same sequence. That's 8, 16, there goes dot, 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 that's infinite. A lot of times for today, you're going to be talking about finite series, so not confusing. Plus 16. We have two formulas, just like you did in arithmetic. We have the explicit formula, which is used to find the nth term. Example, 52nd term. Everything's meant the same thing. First term, the value of the first term is a sub 1. Whatever the subscript is the term number. R is common ratio. And N is the number term you're finding. So like my example up here, 52nd term, you put 52 in for N. And then A sub N, that is just it's notation. You just put A sub 52. This is just the value of the term. You are finding. So, recursive formula is just used to find the next term. You just take the term before it and you times by the common ratio. So this is the term before and common ratio. You do the recursive formula without even knowing you do the formula. Determine if the sequence is geometric. If not, find the common ratio, eighth term in the explicit formula. So to find if it's geometric, it's very similar to arithmetic, except now we just take the second term. So 476, you divide by the first term. If you do the third term and divide by the second term, you get the same number. Both of these, it's geometric. So as you see here, I did both of them on the calculator, and we get 10.1 and 10.01. Those are not the same. Therefore, this is not geometric. It's a sequence of numbers. And we don't have to do anything else on this problem. It'd be nice if all the problems were like that. Unfortunately, they're not. So we'll go on to number 2. So to find if it's geometric, take the first, second term, subtract the first term. Take the third term, I say subtract, I meant divide, by the second term. Those should come out to be exactly the same. 1 over negative 2, well, that's just negative 1/2. And negative 1/2 divided by 1 is negative 1/2. So they're the same. So yes, geometric. And then we have to find the common ratio. Well, if you found that it's geometric, you found the common ratio. Common ratio is 1/2. Multiply 1/2 or negative 1/2. You multiply by negative 1/2 to get from each term to the next. Now we have to find the eighth term, and we use the explicit formula. Let's go back up to the explicit formula. We have a sub n equals first term, a sub 1 times r raised to the n minus 1. We're going to use that formula to find the eighth term. So find the eighth term. We have, well, what's the first term on this sequence? -2. What's the ratio? We have that now already. -1/2. And term we're trying to find, eighth. We have that, so now we can find the eighth term. So a sub 8. So let's find the eighth term. The value of the eighth term is -2 times, I put everything in parentheses, to the 8 minus 1. Put that into the calculator. Okay, so I entered it in the calculator exactly how I see it. Put parentheses around each part. You can do it a different way. I got a decimal here, and we know Mr. Johnson doesn't like decimals. So I'm going to go to the math key, change it to a fraction, and get 1/64. So this tells me that the eighth term is 1/64. Okay, the explicit formula is the last thing we need to do here. The explicit formula is already used. It's used in finding the eighth term. So all you need to do, just like arithmetic, we're just doing a general formula to represent the sequence of numbers. So put it in the first term, put it in the common ratio, we just leave it as n. That's the explicit formula. This is the formula that represents the sequence of numbers of -2, 1, -1/2, 1/4, and so on. Moving on. We need to evaluate, the next thing you're going to have to do is evaluate the geometric series described. So you're going to have to sum up in a finite series. A finite series ends. Series that ends. So finite means it ends. Infinite means it goes on forever. So finite series. Series we're adding. Here's a formula that we use to add up a series of numbers. So it's a sub 1, first term. Value of the first term. We have R, that's the ratio, and N, so whatever term number we're going to. So we'll just write it as ending term number. Alright, so let's jump into it. Number 3, we have to evaluate the geometric series described. So we have, I see 4 series of numbers. -4, 16, -64, 256. And we have to add up 6 terms. Well, I only see 4. So you can either continue with the last 2 and then add them all up, or we can use the formula. I'm just going to use the formula. So the first term, that's a sub 1 in the formula. The common ratio, we don't know that, but we know how to find the common ratio. Second term divided by first term. That's -4, that's your common ratio. And in the formula, we need to know the n, which we already have. You know, 6. So to use the formula, we have first term, -4, times in parentheses 1 minus r, which is -4, raised to the nth power, so 6 is n, over 1 minus r again. I'm putting -4, I put that in parentheses because minus and negative, it gets kind of confusing with 2 negatives next to each other. So put this into the calculator. Let me do that in a second. Okay, so put it into the calculator. I whole thing in because it's a lot of parentheses and you can mess things up. So I'm just going to do the numerator first. So 1 minus -4 raised to the 6th power. I have to put the -4 in parentheses because that's the only thing that's getting raised to the 6th power. So let me rewrite this. -4 and that, and it's for -4,095. So our numerator is -4,095. The denominator, 1 minus -4. 1 plus 4, so that's 5. Now that gets a lot simpler. Let's put that into the calculator. So I did -4,095 divided by 5. And now I'm going to take that answer and multiply. So I multiply by -4. And I get 3,276. So equal 3,276. So if I added up all the numbers, kept going here, and add up all the numbers, you get 3,276. Each time you're multiplying by -4, so it gets big pretty rapidly. Moving on to number 4. So here, you have to add up the first 15 terms. And this one's not so easy yet. Given is that there are 1, 2, 3, 4 terms. I'm going to go up to 15, so I'm definitely going to use the formula. We already know then the formula. We have to find out the first term. That's easy. We need to know the common ratio. Common ratio, just do the second term divided by first. To find if it's an actual geometric series, you should do the third term divided by second or fourth divided by third. But just to find, if you already know it's a geometric series, which is assumed here, just do the second term divided by first. So the common ratio is 1.1. So let's use the formula. Bring that down. So the formula. Yeah, the first term. First term is 1 times, and 1 minus r is 1.1. Always put that in parentheses. Raised to the 15th power over 1 minus 1.1. So let's put that in the calculator. I'll just put the numerator of the fraction in the calculator. So just the numerator's in there. Again, that's not a fun answer. But we can just take this number and divide it by 1 minus 1.1. 1 minus 1.1. That's the denominator. And then multiply by 1, but that doesn't do anything, so I have to multiply by 1. So the answer, in this case, I would say rounded. For your answers, this was a pretty wild number, but so you don't have to write the whole thing because it's not going to be exact. We'll just say with 31.8. Let's put a little wavy equal signs for approximately. Come to class with any questions on this. If you get 17 through 24 done before class, you can use the whole class to retake chapter 6 tests. Thank you.